Hello everyone. This moment I want to share you something regarding how to solve some question in physics paper 2 component 2. This is coming from October November 2019. Sorry 2019. Uh, Actually this is paper 2 AS level. Paper 2 AS level structure question. So, we directly go to some numbers, but don't forget before we continuing our video, don't forget to subscribe, like, comment, or share to others. Yeah, thank you very much for who already subscribe my YouTube channel. Okay, we go to number one. Distinguish between vector and scalar quantities. The vector and scalar. This is about differences about the when the vector uh, that quantities has magnitude and direction, but for the scalar quantities they has only magnitude. Yeah, they don't have about the direction. Okay, question B on number one. The electric field, the electric field strength E at a distance x from an isolated point charge Q is given by the equation, yes, E equals to Q divided by x square B, where B is constant. So, question I is use the definition of electric field strength to show that E has SI base unit of kilogram meter ampere minus 1 second minus 3. Okay, we try to solve this question. So, start from E equals Q is IT divided x square, and B, yeah, B is constant, yeah. So we have, let's say we have about the we directly about the unit, yeah, unit. So sorry, so has oh sorry, uh this is not from this equation, but we start from definition of electric field. The electric fields mean F divided by Q. Yeah. So F is force. This is the, let's say, MA, and Q is, let's say, IT. Yeah. Sorry, I times T. Then if we see the unit, yeah, of this equation, so we have mass is in kilogram and acceleration is meter second minus 2, then I is ampere and T is second. Yeah, so we can say this is kilogram and meter and ampere minus 1 and second minus 3. Yes, this is same thing with this one. Yeah, okay, continue to next number. Use unit of E given in BI to determine the SI base unit of B. Okay. Okay. We have E as IT divided by x squared b. So we have from this uh, equation we have IT divided by x squared e. So b, yeah, we said, but the unit, yeah, unit of b, yeah, I as ampere and t in second, and then x in meter, then square, and a, this one, yeah, a as kilogram meter, and we can say this is ampere, this is second 3. So it's like kilogram minus 1, then meter, we see meter is 2, yeah, meter minus 2 because coming up, and ampere over 2, and second is 4, yeah. Okay, this is the unit of B, yeah, kilogram minus 1, meter minus 2, ampere over 2, and second 4. Okay, continue to next number. Yeah. Don't forget, we will before we continue our questions solved, yeah, for subscribe my YouTube channel. Yeah. Thanks for everyone who already subscribed it. So question 2 is about the define the acceleration. Yes, the acceleration means as the velocity gain after time taken. So acceleration is gain of gain velocity after time taken. Yes. Okay, then question B. Yeah. A steel ball of diameter 0.8 is raised from rest and fall vertically in air as illustrated in figure 2.1. This is the position of ball when released. The steel ball in diameter 0.08 meter and the height is 0.20 meter. This is position P ball, yeah, and horizontal beam of light of negligible white. So a horizontal beam of light of negligible width is vertical distance 0.28 meter below the bottom of the ball when it's released. The ball falls, stroke, and breaks the beam of light. So number 1, yeah, question I. Explain why. Yeah, explain why the force due air resistance acting on the ball might be neglected when calculating time taken for ball to reach a beam of light. Okay. Because this is free fall, yeah, because this is about the free fall. So they don't have acceleration except gravitational acceleration. Let's say this is around 9.81, yeah, meter second minus 2. Okay, Continue to the next number. Yeah. Calculate time taken. Calculate time taken for the ball to fall from rest to position P, where the bottom of the ball touches the beam of light. Time taken, yes, this is about when reach uh, ball has, let's say, we can use h equal to vot plus a half gt squared. We have this is 0.280 meter, and position ball release, the ball when released, the velocity coming 0 t plus g is 9.81, then t square. So we can say t square is 2 times of 0.280 divided by 9.81, and we can use the calculator. So uh, 2 times with 0.280, yeah, divided by 9.81, it's become 0.057, and we root it, and 0.238 something, or we can say this is 0.24 with second. Yeah. Okay, continue again to the next question. Determine the time interval during which the beam of light is broken by the ball. Yeah. Okay. Time interval during which the beam of light is broken by the ball. It's okay. We see again for okay. Actually, beam of light has a velocity, about ray velocity around. Okay, you can see this one. We have the velocity of ray. This is around 3 times 8 meter second minus 1, and we have distance about 0. I want to open again, 28 meter. So time equals to x divided t, so x divided v. So we have 0.280 meter divided by 3 times 8. So we have 0.28 divided by 3, it's around 0.093, yeah, times minus 8. So we can say this is around 9.3 times minus 10, yeah, or 9.3 times minus 10 second. Okay, continue to the next question. A different ball is released from the same position as the cell ball in B. This ball has the same diameter, but it's much lower density for the ball. The force due to the air resistance cannot be neglected as the ball falls. State and explain the change, if any, to the time interval during which the beam of light is broken by the ball. Yes, this is about the when the ball has diameter. This is around. I'm sorry, I want to again diameter 0.08 meter. This is 0.08 meter. Yeah. So when the velocity of beam is around 3 times 8 meter second minus 1. This is v of light beam. So we can say about time. Yeah, time is 0.08 meter divided by 3 times 8. Yeah, we can say this is about 0.08 divided by 3. It's equal 0.0266 something times minus 8. Yeah, so we can say this is around 2.6. Yeah, times 10 1 2 minus 10 second. Yes, this is time interval, yeah, during which the beam of light is broken by the ball. Okay, continue other question. Yeah, we have about the collision. Yeah. State Newton's third law of motion. Yeah. Third law of motion. This is about the action and reaction. Yeah. The total force, yeah, in action. Yeah. This is equally with total force in reaction, but in different uh, different direction, or this is opposite. Yeah. Okay, we see on the B question. A block X of mass mx lies in straight line along a horizontal frictionless surface as shown in figure 3.1. This is mass X, speed 5v, and mass Y. Yeah. The block X moving with speed 5v collides on with the stationary block Y of mass my. The two blocks stick together and then move with common speed v, as the shown figure 3.2. Use the conversion of momentum to show that the ratio my divided by mx is equal to 4. Okay, when we use the conservation of momentum, we can say that mx times vx plus my vy, yeah, same mx plus my times v. So when the mass is equal, yeah, we block something. No, equal. We find about the ratio my and mx. Yeah, mx vx is 5v, and my vy is 0 because this is coming from rest. Yeah. Then this is mx plus my times v. So 5 mx v equals with mx plus my times b. So we can cancel about b here. So we have this for mx equals to my. So this is my divided by mx, this around 4. Yes, this is something good. Question II, calculate the ratio total kinetic energy of X and Y after collision and total kinetic energy X and before collision. Yes, this is main amount kinetic energy. This is only mx vx squared, then my vy squared divided by a half mx plus my v square. Yeah. Okay, sorry, because this is there is no move for vy, so we can say it's only a half mx vx square vx sorry, fvx is 5v, this is 5, sorry, we cancel here a half mx 5x vx is 5v square divided by a half mx and my, and then this is v square. So we can say we can cancel a half one, and mx 25v square divided by mx plus my divided by v square. For the first we can neglect it, we can cancel for v square. Then we have about mx and my. Mx times 25 divided by mx plus the my is 4 mx here from this one. So we can say this is 25 mx divided by 5 mx. Can cancel mx1, and 25 divided 5 is 5. Yes, the answer is 5. Okay, continue to other question. Question III. State the value of the ratio in II for a perfectly elastic collision. Ratio in I, sorry, want to open perspective. Yes, the ratio actually 5. Yeah, that's kinetic energy before, after, and before of xy. The variation with time t momentum block x in B, yeah, is shown in figure 3.3. Yeah, this is momentum, and this is time in millisecond. Block X makes contact with Y at the time t 20 millisecond. Describe quantitatively the magnitude of direction and resultant force, if any, acting of block X and time interval t from 0 to t until 20 milliseconds. Okay. uh, as we know about the momentum, is about the uh, force, yeah. mm, okay, okay. mm, mm, mm. 220. Oh, okay, I see. Okay. uh okay, force equals to delta p over delta t, yeah. So uh, force equals to delta p, it's mm, wait, the person diagram. mm. This number, yeah. Okay. Yes, this is actually mv. V is 5v divided by time is 20 millisecond minus 3, so we can say this is 5 mv times 3 divided by 20, so actually like 0.25 mv times 10 3. So what about 20 to 40? This is about the uh, uh, trapezium shape. Yes, the momentum it's equal with actually we don't have about the number here, yeah, so we don't know about how to solve this question. Okay, I think enough for this session. Thank you very much for watching my video. Don't forget to subscribe, like, or comment. Thank you very much. Bye bye.